So I want to use an example here to highlight the power of service brokers by looking at our external domain service and what we actually do behind the scenes, a fairly complex dance when you go to create an instance of our CDN service. So our CDN service, CDN stands for Content Delivery Network. This allows you to bring your custom domain to Cloud.gov, but also to create worldwide caches of your content for high volume applications, for high throughput, or for distributed user bases that are all throughout the world. So when you use our CDN service, you are actually asked to do two things in your DNS. So as a customer, we ask you to create two CNAME records or canonical name records. The first one, we'll start with _ Acme Challenge dot whatever your domain is. So we'll again say example.gov. The second is for your domain, example.gov. Okay? Now, these values that we actually ask you to set will correspond to values that are referenced in our DNS. So we use Route 53, which is an Amazon provided DNS service. And so these records will essentially point to records that we actually have control over. And this is important because the service broker uses these records to actually complete this fairly complex dance of getting your CloudFront distribution running with a certificate that is valid for your domain. So the first thing that the broker does when you actually provision an instance of the CDN service is it goes to fetch a certificate for example.gov. And it gets a valid certificate from a third-party service called Let's Encrypt. Now, Let's Encrypt doesn't just issue certificates for any domain. What they make you do is prove that you actually own that domain and have access to that domain so that they don't, inadvertently generate certificates that, could be used maliciously to spoof your domain. Now, in order to do that, Let's Encrypt issues a series of challenges. And so in our case, we get issued a DNS challenge. What that DNS challenge says is Let's Encrypt servers want to be able to reach out and do an NS lookup, do a name service resolution on a specific entry, in our case _ Acme Challenge.example.gov, and see the value that they tell you to set. Okay? So the reason that we have you set up this CNAME record is so that whatever Let's Encrypt says is the DNS challenge, we can set that in our DNS, and it is just basically a text string, so that when Let's Encrypt looks up acmechallenge.example.gov, the response that they get is the appropriate response. Now again, you aren't asked to do this anymore. In previous versions of this broker, you actually had to solve this DNS challenge yourself, but we've come up with a way that you don't need to do it anymore. You can instead just set up a CNAME record. So what we get back from Let's Encrypt is a valid certificate for your domain being example.gov. That certificate is good for 90 days, and the broker will automatically renew that certificate as long as you're using this service. So you don't have to worry about the certificate actually expiring. So we have a certificate. The next step, what the broker does at that point, is create a CloudFront distribution. So it does this by calling the Amazon APIs. And what this is doing is creating the CDN distribution. That CDN distribution that gets created has its own DNS record. It'll be, some mix of characters .cloudfront.net. We create the distribution. We find out what this CNAME record is. And we then configure the value over here in Route 53. As part of this process, you've also supplied to us what is the origin or what is the source of truth for your application. That gets configured in CloudFront. The certificate from Let's Encrypt gets configured in CloudFront. And when that distribution actually gets created, the process takes roughly 30 minutes or so. You have a running CloudFront distribution distributed worldwide for example.gov with a valid certificate. All you needed to do to actually have that happen was do cf create service and set up 2 DNS records.